atomic swaps between BTC and CYP. So that would be from Bitcoin to Cypher. So how this gets achieved is what's called an adaptor signature. There's a paper out there written by Lord Fournier. Sorry if I didn't get that correctly, but I strongly suggest that you go give this a quick read. It's not that long of a paper, but it's very intuitive, explaining exactly how adapter signatures would work in a real application. So it will go through the introduction. It will explain to you what's a fair exchange without a trusted party. What are scriptless protocols or scriptless scripts, and it gets explained in this section over here. And this is obviously explained by Andrew Palestra. So the atomic swap basically happens between two currency pairs on either chain or on two different chains. This explains how the atomic swap actually happens and what needs to happen before the other one moves to sign the signature on each address. The paper also goes into explaining on what it can be used for, so i.e. payment channels, and I know the Lightning Network uses payment channels, and they would obviously use this using Schnorr signatures to achieve that goal. The paper also goes on describing, you can use it with tumblers, lotteries, and paying for a commitment opening. And this is pretty interesting. How would you pay for a Patterson commitment? So with that, let's show you the demo. Is to control the Bitcoin addresses. They would obviously go and create the same key pair generation for Cypher, so that they both can control the address, but neither of them can actually spend the transaction when Alice actually moves her funds into that address from Cypher. So just a bit of a blurb here, and this is a copy paste from a previous website that I've been looking at, which is the Rust implementation from BTC to Monero. So my implementation is sort of similar, but I think where it differs is that I'm using the same elliptic curve scalar on my side. That would be used the exact same scalar that's been used on BTC. So with that, basically they'll have a shared public key, which is a view key, which is either Bob's private key, Bob's private key, sorry, the spend public key and the view public key, right? So they will know each other's key pairs, and what they keep secret is Bob's scan key, and then spend key, and Alice's view key, which she then obviously doesn't give to him, but she will give to him once the swap is complete, so that Bob can take over the address. So obviously someone knowing both spend A and view A, which is spend Bob and view Alice, will be able to spend the outputs in the cipher. Right? So again, it goes into assumptions, the amounts being exchanged, and obviously the absolute time locks. So the time locks prevents either one moving first or second, or vice versa, depending on what the time has been set on each blockchain. So what Bob will do is he will construct a cipher address where Alice will eventually lock up her cipher and share the outputs SB, which are the public key for spend and public key for review, verify. So what she does is she encrypts using a secret key. In this case, it would be Alice's Bitcoin private key, and she then takes the encrypted public key, which is a public key from the cipher address, and she will then encrypt it, producing an adapter signature. And she can then verify the adapter signature is correct, that the same secret key was used to create this encryption. So that obviously passes, and we can move on to the next step, where she then decrypts the adapter signature with the view key, which is the private key that she wants to leak. Well, she has control over it in this case because she's doing a self-test. And once she publishes the signature on her address, which is controlled only by Alice at this point, it will then obviously either verify true or false. Right? So once it's on chain, which is the signature that controls this address because it's now been signed, Alice can then go and do a recovery using the decryption she got from here, the adapter signature, and then obviously the encrypted public key, which she then obviously has shared with herself. And this should obviously tell us that if this is the correct key and what is recovered. Bob, however, goes and does exactly the same test, so we're not going to go through this. But the third test is obviously where we want to prove that we can do the same thing without revealing the secret in any way, or using a hash time lock, which is normally the case in a Bitcoin 2 of 2 or 1 of 1, where each party would use the first party's secret to unlock the box on either chain. So in this case, or in this scenario, there is no secret key that gets exposed on chain, or the hash or the preimage of the secret key. They use the adaptive signature to hide the key within the signature, and they exchange these adaptive signatures, so either party signs for either party's address. So the fair exchange basically is more secure, there's no leak. What you're actually doing, it's basically just looks like a 2 of 2 multi-sig, or just a signature that goes on chain. And there's no way for, in this case, to actually pinpoint you're actually doing a swap on 2 different currencies, and there's no way for anyone to see that those addresses actually belong to the currency you're trying to swap for, because of the nature of how the cipher self-address works, or the self-addresses work that you generate at one time, public key that controls the spend output. So what happens in this exchange is that Alice moves first. She encrypts using her Bitcoin private key, and she uses a view key, a public encryption view key, and then just passes a hash that they're going to sign. It can be anything. So then Bob verifies. She sends this over to Bob, and then Bob verifies what her adapter signature is using her Bitcoin public key, the message that they agree on, and then the encrypted public key of the secret that they want to leak. Right? So he then verifies that this is correct. Then he responds back by generating a signature on the same key, right? Because we want to be signing on Bob's address. Alice needs to produce a signature that only Bob can produce if he's got the private key. But because we're mixing Bob's adapter, we can then say that Alice can actually sign for Bob. So this is sort of like a Defi-Harmon key exchange, except that it produces a valid signature on the public key that we're trying to sign on for. So there's no way for Alice to cheat Bob, because Alice can't produce a valid signature if she hasn't used Bob's adapter signature to produce the signature. So there's no cheating. There's no way Alice can scam Bob, and vice versa, because neither of them can produce a valid signature on each other's public key addresses, or under their public key addresses. So Alice decrypts the signature because she wants the BTC, and she produces a valid signature for Bob's public key, and we can verify this by taking the decryption signature with Bob's public key, which means that in a way Bob actually created the signature using his private key, but the result by using the adapter signature is because we want to leak the secret that controls some sort of value to some lockbox, whether that's any other cryptocurrency or maybe just a key exchange. So, and it's obviously one time. One time doesn't really mean to say that if we generate the same sort of steps, it will obviously generate the same sort of sequences. But one time meaning it will only be spent once, right? So what he does is he then obviously sees that Alice has signed his Bitcoin address to release the funds. Then he moves, and he can actually see that by taking Alice's decrypted signature, which is in fact a signature for Bob's public key, for his Bitcoin public key, and he takes his adapter because he's passed it to Alice, and Alice can't produce a valid signature on Bob's Bitcoin public key, and he takes the encrypted public key that they shared in the step to encrypt and create the adapter signature. And if this all works out, it should be the same as what she's trying to leak through the encrypted public key. So if we just run this demo quickly. So as before, we're gonna step through the library and we're gonna create all the little goodies we need. We need the BTC keys, the Bitcoin private key, and she's gonna use her Alice's view public key and with a message that she wants to sign, and she's going to then encrypt it, and then she's going to verify that they indeed share the same private key to the encrypted key that they're going to leak, right? So he verifies it, he goes and checks it, and it comes back as true. Now Alice is satisfied that her self-test is working. Now she's going to go and decrypt her adapter signature to produce a valid signature. So she takes the secret that she wants to leak, because that's a decryption key, and the adapter signature that she produced, and she's now going to go and decrypt it, and she's going to verify that she's the only one with the leaked secret, but she's also the one that can only sign on her address, right? So that is true, and then because that's true, and she publishes it onto the chain just as a self-test, she then recovers from her adapter signature, from her decrypted signature that signs her address, with her adapter signature and Alice's view public key, right? So she recovers, we just do a test to see if that is the actual key that we're trying to leak through this adaptive signature, and that comes out to be true, right? So we've now got the view private key and the one that we want to leak, right? And we know that by producing this adapter signature on the encrypted adapter output, we can then sign on our own address, which is in this case I control the address, or Alice controls the address, but she has the private key to a Bitcoin address, and that's the public key that verifies anything that goes through it, which is either a signature or whatever the case is. Bob does exactly the same thing. He does a self-quick test. He just takes his Bitcoin private key, his spend public key that he wants to leak to himself. He then verifies or encrypts the adapter signature and verifies that it is true. He will say, yes, it's true. Because that is true, he will then decrypt it with his spend private key and using his adapter and producing a valid signature, which means that if it is true that Bob actually signed it using the adapter signature, and there's no other way for producing the signature other than going through these steps, that Bob controls the private key to this public key, right? So that's true, and then because the signature is on chain, we then want to recover the leaked secrets through the signature that was decrypted using the adapter signature and using the encrypted public key. So we recover, and we're just making sure that the Bob spend private key is actually in fact what we're going to leak to ourselves, and that is in fact true, right? So now we start with how this would actually work on chain. So what Alice does is she uses her Bitcoin private key, and she wants to leak a secret, and she uses her view key, public key, to do that. Okay, so she passes this to Bob. Bob then verifies that this is correct. So we would say that the adapter signature that she produces from the encryption is in fact the Bitcoin address that she's using as a secret key, and this is the key that she wants to leak, and it all verifies true if everything is correct in the protocol. So he verifies it, he says okay, it's true, then Bob will then obviously respond by generating a signature under the same key. So this is very crucial, otherwise it's not going to work. So Bob takes his Bitcoin private key and he encrypts it with an encrypted public key, which is going to give Alice the right to produce this signature so that she can sign on his address that he controls with his Bitcoin secret key that she doesn't know, and she can't produce a valid signature any other way, right? So he gives her his adapter signature. She then decrypts the signature and publishes it on chain. So she decrypts this signature that she got from Bob, which is his adapter signature, and she uses the view key, private key, the private view key, to decrypt the signature. By doing so, she creates a valid signed signature that in fact comes from this address, which is Bob's public key. And there's no way Alice can produce a signature other than using Bob's adapter. Okay. So when she publishes, and we want to test that this is true, when she publishes that we can see the outcome is true. Now Bob sees that Alice is now going to sign his address. He then can go and recover this adapter signature, knowing that Alice assigned his Bitcoin address with his adapter signature. And what he does is he takes the decrypted signature, which is in fact his signature that he created for Alice because of the adapter, and he uses Alice's public encrypted key. Okay, so if it all works out, he will now then learn what is leaked from Alice. Okay, in this case, it's the view private key. Right? So if it all works out, we will now see that indeed the protocol works. So we started off with Alice's private view key, and we did a self-test and we leaked it to ourselves, and it all worked out fine. Bob does the same thing, however we haven't done the fair exchange with Bob yet, so we're only doing it on Alice just to prove that this is all correct. So Bob verifies the encrypted signature, it's true. He then pushes publishes the signature on Bob's address, or Alice publishes the signature, which indeed Alice can't produce a valid signature on Bob's public Bitcoin address. If she wants the funds, she would have to play nice, and she has to be honest, otherwise the whole thing doesn't work. So that's atomic part. And then obviously seeing that Alice pushes the signature, claiming the funds, he now knows that he can get the secret key from that public encrypted key. So this is how atomic swaps will work in Cypher, and it's pretty easy. Well, it took me about 5-6 days to come up with this, writing all the code and obviously putting out and laying out the protocol and making sure that I understand exactly what's happening in this paper. So if we wanted to swap Monero to BTC, Monero to Cypher, or vice versa, we would have to obviously use the cross-chain DALEC algorithm, but because there's already code that's already been written, and Cypher is synonymous in terms of scalar to Bitcoin, it wouldn't be a problem to actually take the Rust code and then just produce the same sort of events or same sort of outputs to produce the same results on the BTC side. However, it would just work slightly different. Going on to Ethereum also supports the libspec scalar, the 256K1 scalar, so I don't think there would be any problems in doing that. I read some paper somewhere, or some funding that has been awarded to some people or researchers to do the same thing with Ethereum from Monero to Ethereum. However, I don't know if they've achieved their goal, but they have definitely produced a project and a demo to prove that this is possible. However, they have certain constraints in terms of the contract not maintaining state, and there's something to do with amounts that can't be produced, so they have to do it in some other way. In our case, obviously, this isn't the case. If we want to do atomic swaps with ERC20 tokens, we would obviously just create a smart contract that calls the ERC20 token side. So I'll be creating the Bitcoin scripts to do exactly what this protocol is intended for. If there's anybody that wants to help out with the Bitcoin side or the scripting side, give me a shout in Discord. It would be greatly appreciated, because I'm busy with all different stuff. I need to still do a GUI wallet that runs on mobile and desktop, and different flavors of OSs. So this is just a quick demo showing you that this does in fact work, and hopefully we can have this in by the launch of Cypher when we go mainnet, 20th of December. I don't know how many days it is, if you look that up, but I'm running out of time. Anyway, so if you've got any questions, give me a shout. Once I've got everything in place, I would obviously release the code so that you can have a look and have a play. But this is just a quick demo to show you exactly how this gets put together. So I'll either catch you on Discord or Telegram, and it's actually afternoon, so have a great day.